Is absence of evidence of absence in all cases or some cases?
Some cases, but I
Okay,
would.
good. Okay, good.
Absence of evidence is evidence of absence, even when you don't expect to see the evidence. This follows from Bayes' theorem. Bayes' theorem is a mathematical tool that is used to update your confidence in a hypothesis as you get new evidence. This is the odds form of Bayes' theorem. The posterior odds ratio equals the likelihood ratio times the prior odds ratio. To see how Bayes works, let's go through an example. Suppose we are wondering whether Sally is a presuppositionalist. We have hypothesis 1, Sally is a presuppositionalist, and hypothesis 2, Sally is not a presuppositionalist. To see how Bayes works visually, start by drawing a box. Let's suppose that our prior odds ratio is 1 to 5. Divide the box to represent our prior odds ratio of 1 to 5. We are 5 times more confident in H2 than H1, which is represented by H2 having 5 times the area of H1. Suppose we know that there's a 50% chance of Sally being a troll. Given that she is a presuppositionalist, we can represent that visually. And suppose we know that there's a 10% chance of Sally being a troll. Given that she is not a presuppositionalist. Again, let's represent that visually. Next, suppose that we gain new evidence that Sally is a troll. When the new evidence comes in, erase the other parts. In this case it's the red area. Our likelihood ratio is 50 to 10. Our posterior odds ratio is 50-50, or 1 to 1. The posterior odds ratio can be seen visually as the ratio of the areas of the two blue rectangles. They now have equal areas. To sum up, we started with a prior ratio of 1 to 5. After we learned that Sally is a troll, we updated our ratio to 1 to 1. We gained confidence that Sally is a presuppositionalist. Next, let's use an example to show that absence of evidence is evidence of absence, even when we wouldn't expect to see the evidence. Consider a very small bug. Most of these bugs are too small to be seen. We have two hypotheses. There is a bug in the box, and there is not a bug in the box. Start by drawing a box. Suppose we start off at 50-50 on whether a bug is in the box. Divide the box in half to represent our prior odds ratio. If there is a bug in the box, there is a 75% chance that it is too small to be seen. If there is no bug in the box, there is no chance to see a bug. We look in the box, and the new evidence is that we don't see a bug. When the new evidence comes in, erase the other parts. In this case it's the red area. Our likelihood ratio is 75 to 100. Our posterior odds ratio is 75 to 100, or 3 to 4. The posterior odds ratio can be seen visually as the ratio of the areas of the two blue rectangles. To sum up, we started with a prior ratio of 1 to 1. Upon not seeing a bug, the ratio went to 3 to 4. Our confidence that there is not a bug in the box increased. As long as there is a non-zero probability of seeing the bug, absence of evidence is evidence of absence, even when we didn't expect to see the bug.